before, and I just used to hear my voice just, you know, a lot. So it's great right now. Hello everybody, good afternoon. My name is Chidem Shanol. I work for RIPE CC Learning and Development team, and today I would like to present Internet routing security. So it's much more technical topic. Right now we are moving the more technical topic after the country presentation report, and I would like to discuss, I would like to explain at least what we should do for more secure and robust internet. So, as all you know, BGP is the protocol of the internet nearly for 30 years, and still there are no alternatives. But this de facto protocol comes with some security challenges because it was designed in early 1990s, and internet usage was not common on those days, or security was not an issue because internet was not a critical infrastructure back then. So that's why it was not designed with security in mind. That's the reason there is no built-in security in BGP to prevent incidents. It could be attacks or it could be just accidents, let's say. And unfortunately, it's just based on trust. So whenever your BGP peer tells you, you always assume that this information is correct, and you just extend it without verifying this information. So as a result, actually, as you can imagine, there is no verification of the correctness of prefixes or ASPs, so we don't know who originated the prefix is really the legitimate resource holder or really authorized to put this prefix in BGP. Or if somebody tampered with the ASP, we have no idea. And due to these vulnerabilities, many BGP incidents happen every year. And some of them are, you know, of course, as you can imagine, they are attacks caused by the attackers. They are malicious activities. But the reality is that most of them are just human errors. They are caused by the configuration mistakes or typos. Some of them are really very short-lived, they recover very quickly, and they have only local impact. That's not a big deal, by the way, but some of them are really very disruptive. And they actually impact internet routing at a global level, and they actually impact really very big parts of the internet. And because of there is no built-in security in BGP, NAS can announce any prefix. So you can announce a prefix which is not yours, and you can hijack the others. It is so easy. Unfortunately, we cannot say, or it's really very difficult to say, if it is an accident or if it is a malicious activity. Or NAS can prevent any ASL to the ASP, which will end up with path hijack. Prefix hijack, path hijack. Both of them manipulate the routing information. So, by executing those attacks, attacker can put incorrect routing information into the BGP table and reroute traffic according to their intentions. It can reroute traffic to its own network, and then it can blackhole it. So which will cause denial of services. Nobody will be able to reach your network. Or it can just divert traffic to its network to intercept, analyze it, in order to access private information, and then we'll send it back to the, or we'll send this traffic back to the legitimate destination. And as long as traffic reaches to the destination, nobody will notice something is happening, because if it doesn't break, unfortunately, nobody will be able to understand that. Of course, you can have some monitoring tools to detect it. If you notice that traffic is following a path different than usual, but it's possible that attacker can also hide this TTN and hide these tracks as well. But as a result, many BGP incidents are happening, and incorrect routing information is propagated and to the internet and disrupt internet routing. So the question is that, what should you do for secure routing? How can we make internet routing infrastructure more secure, more reliable, more robust? There are some recommendations for that, and we can actually group those recommendations underneath 3 main groups. The first thing is that do not be the cause. Do not cause BGP hijacks. While you're announcing the prefixes, check them. Be careful there. Be careful with the typos, and make sure that you are announcing the correct prefix. You are not hijacking someone else by mistake. And have proper filters in place. If you are the service provider from your customers, you should supposed to accept only customer prefixes. not anything else. And also, you should have proper outbound filters as well, so that you should not leak the routes that you get from one transit provider or peer to another transit provider or peer. Second, do not distribute others' attacks or others' mistakes. So which means that validate the routing information you receive before putting it down into the BGP table. Implement origin validation, implement RPKI. So if somebody else just makes the mistakes or try to attack another network, when you get this incorrect routing information, you can detect it and filter it out, and you can restrain this wrong information, prevent it from propagating to the whole internet. And of course, do not be the victim. Do not let other people, other networks attack you. Take all the measures you can. And also, not your network only, not your prefixes, also protect your customers. And always keep in mind that there is not a magic stick, or there is not a only single security measure which will fix all the problems, all the BGP instances. There are several security measures that should be implemented. So what are those? Let's have a look. Have proper filters in place. So filtering is the basic protection mechanism, and it's really very crucial, because BGP propagates everything by default. There is no policy in BGP by default, which means that when you have the BGP session, you will accept everything from your BGP peer, and you will send everything, whatever you know, whatever you have in your BGP table. And as a result, incidents will occur. So inbound filters are critical. They play an important role to detect configuration mistakes. For example, from your customers, you should have filters in place to accept only customer prefixes, so that you can filter it out to incorrect information in case your customers originate some hijack. And outbound filters, they are important as well, so much important to eliminate the route leaks, so you don't actually leak the routes from one transit or from one peer to the other transit or peers. So how should we configure these filters? You can configure filters, or you can decide what to filter, which prefixes that you want to accept or reject. If you don't know actually the whole prefixes that you want to accept or reject, what you can do, instead of creating prefix-less filters, you can also create your BGP filters, or filter the routes based on ASP information. You can create them manually or automatically from the IRRs based on the registered routing information in the IRRs. For secure routing, the important thing is, it's really very important, validate the received routing information. So make sure that the network who is originating the prefix is really the legitimate resource holder or authorized to originate that prefix in BGP. But how can we know that? How can we achieve that? That's why IRR system was introduced. IRR is the Internet Routing Registries where network operators register their BGP announcements, document them in their databases, so that they create some objects, rather route 6, to declare that this is my prefix, and this is authorized to originate or supposed to originate that prefix in BGP, and other network operators create BGP filters accordingly or use this information in order to do better routing decisions. Many transit providers and exchange providers perform IRR filtering, by the way. But automation relies on IRR being complete. That's another thing, because there are some concerns with the IRR system, which I will mention in a minute. But that's the reason RPKI was designed to complement and expand its routing security efforts. Different than the IRR system, it's based on regional registries and it uses cryptography. So RPKI validates the routing information to receive routes based on trusted, accurate, and up-to-date RPKI data. But what about the BGP path? Okay, we are validating the origin of BGP announcements, but what about the BGP path? How can we ensure that nobody tampered with it? How can we ensure that the ASP information in the BGP update, does it really reflect the ASS the update packet has triggers? In order to do that, we need to verify the whole BGP path. And RPK is a stepping stone to path validation, which means that now today we are using RPKI to validate the origin of BGP announcements, but it is also the infrastructure we will be using for PET validation as well. And for PET validation, BGP-SEC was defined with this RFC 8205 some years ago, but still it's not in use. Still it has not been implemented by the vendors because it requires a lot of resources, because it requires the router to sign the ASP information each time it receives the BGP update, and before sending it to another BGP peer and the other BGP router, whenever it receives it, it needs to validate the whole ASP. It requires a lot of resource on the router, more powerful router. So that's why still there is no implementation. And that's why there is some more lightweight solutions are in the pipeline right now, such as AS-PON, such as ASPA. ASPA is Autonomous System Provider Authorization. It is something very similar actually, or the way of how the things will be done, similar to RPKI ROS. So the customer autonomous system will be creating an ASPA object, digitally signed object, and say that, okay, I authorize this ASM to be my upstream and to announce, to propagate my prefixes in BGP, and we sign it with this private key and we put it into the RPKI system so that other network operators can use this information. Internet routing register it's still important, very important for routing security because it's the most widely used method right now. And when we look at the RPKI, still we are promoting it because once more and more people implement RPKI, we will have more and more data in our disposal actually to use and to verify the received routing information. But for the time being, Internet routing registers are widely used and those are routing policy databases, so network operators are documenting their routing policies. The prefixes they are actually announcing. So the other network operators can use this registered routing information to make better routing decisions, to validate the origin of the announcements, let's say. There are many IR databases are available. Some of them are run by regional registries. For example, as RIPE NCC, we are operating RIPE database. But some of them are also run by different organizations, such as RADB, such as Level 3 and TTCOM, the providers, and there are tools available that can extract the routing policy information from those IRR databases, such as IRR Toolset, IRR-PT, or BGP-Q4. What they do, they query the IRR databases that you want via queries protocol, and they look for the route 6 objects by running an recursive lookup. They look for the route 6 object associated with the ASs listed in this AS set and extract the prefixes from those objects and creates the BGP filter configuration. Some of the tools just gather the prefixes, some of them create the full BGP configuration. Some of the tools are well maintained, some of them are not, but most of them are open source tools. So I want to just demonstrate, I will not do any configuration, just show it with the slides by the way, just you have an idea if you have never tried it before. BGP Q4 is really very widely used to generate BGP filter configuration by the way. What it does, it gathers information from the IRR database, and here what you see that I'm actually querying for AS3333, and what happens, BGP Q4 queries the database, IRR database, which IRR it is by default, I don't remember by the way, but you can define the source, which IRR database to use by using -as parameter. And it will look for the route 6 object associated with this AS number or AS that I provided, and will gather the IPv4 prefixes. You can do that for IPv6 as well, but what you need to do is just put -6 parameter. By the way, when you just write BGP Q4 and press enter, there are many parameters and it shows you for which environments you can do or you can generate prefix filter configurations. By default, it is just for Cisco, but you can do that for the others as well. You can give a name to your policy by using -L parameter. You can generate this filter for Juniper, for OpenBSD, for MikroTik, Nokia, Huawei, any vendor environment which is, and also many open sources as well. And there are some issues, by the way, with the IRR system. Maybe you know, maybe not. IRRs are distributed databases, so which means that conflicting information may take place in two different IRR databases. And in this case, which one we should trust? And there is no central authority for the IRR system. So how can we know that the information in the registry is up to date, is accurate or not? And the other thing is that there is no holdership verification for some of the IRRs. For example, in the right database, we verify the holdership, which means whenever you want to register your BGP announcements, while you are creating route and route 6 object, what happens actually, we verify if you are the legitimate resource holder, if it is your block. If not, you are not allowed to register this routing information. It's not correct for some other IRR databases. Even if it's not your prefix, you can just go ahead and create route or route 6 objects for a prefix if it has not been created or it has not been registered by creating route or route 6 object the day before. So, and also, unfortunately, the information in the IRR is not complete because some people announce their prefixes but forget about putting this information to the IRR system, or the other way around. They just stop announcing but forget about removing it from IRRs. So that's the reason IRR entries are good, but as long as they are correct and complete. Because of these issues, RPKI system was implemented to complement these routing security efforts and expand them, which is resource public key infrastructure. It's a security framework designed by IATF. Different than IRR system, it's based on regional registries. There is a central authority here because since there is a contractual relationship between the regional registry and the resource holder, then regional registry can verify who is creating an object in the RPKI system. And it also uses cryptography. It attaches digital certificate to IP address and AS numbers. It provides data you can trust. And here we are using cryptography. RPKI is using cryptography to verify the association between the resource holder and its resources. When we look at the certificate structure, regional registries are at the top of this hierarchy. They are trusted authorities, they are trust anchors, and they are running root certificate authority, and they issue certificates to the end user. It could be an end user, it could be an LAR, and this certificate is the proof of holdership. The LAR certificate, which is issued by root CA, proves that the LAR is the legitimate resource holder for those prefixes and has the right to announce those prefixes, to register those BGP announcements in the RPKI system by creating laws, by creating authorized statement. So it says that, hey, this is my prefix, and I authorize this ASM to originate this prefix in BGP and signs it with its private key. And after that, the other network operators download this information, validate the chain of trust, all the keys and signatures, and then they actually, the validators, I will explain later on, there is an application or software, let's say, we need to install into our network in order to do that, and validator will validate the chain of trust and will generate some payloads. And for ROAS, authorized statements in RPKI, VRPs, validated raw payloads will be generated. And for ASPA, it will be VAP, but currently only ROAS are of practical use. So how does RPK enable routing security? So it has two parts actually, signing or validation. Signing means that you are creating ROAS, route origin authorization, authorized statements. You are saying that this is my prefix, I authorize this AS number. It could be yours or any AS number, maybe your providers, to originate that prefix in BGP, and you sign it with your private key and publish it to the RPKI system. And validation means that you are verifying the information provided by the others. So you are downloading all this information from the RPKI system, validating the chain of trust, and now you have VRPs, validated ROAS or valid ROAS. And then you use this information, this valid RPKI data, to verify the origin of the BGP announcement. And these two parts are completely separate from each other. You can create ROAS and put them into the RPKI repository to protect your prefixes. Also, you contribute to global routing security. Or you can do only the validation part. Again, you contribute to global routing security and also protect your networks because you just stop wrong information, by the way, and it's not distributed. But of course, if you want to feel the full power of RPKI, you should do both. In the signing, you just create ROAS authorized statements in the RPKI dashboard, sign them and publish them to the RPKI repositories, and in the validation part, you will download this information, the RPKI data in the repositories, and validate it. In order to do that, you need to install validator software, and validator will validate the keys, signatures, it will validate the chain of trust, and this validated raw payloads or valid information, valid RPKI data will be sent to router via RPKI RTR protocol and will be used to make better routing decisions. There are several validators available, by the way, and they are written in different programming languages. It's up to you which flavor to use, but we recommend you to use at least 2 validators for redundancy, because if one of the validator connection with your router fails, then what will happen? You can still go on getting this valid raw information to make better routing decisions. But if you have only a single validator, which means that you don't have this information and you will start accepting the BGP announcements that you should be discarding. RPK has 2 flavors, by the way, hosted and delegated. Hosted RPK is the most widely used and really very easy, but it's just one-click setup. What do you need to do? You just go to the RPKI dashboard of RIPE-NCC, create ROAS, your authorized statement, and they say that those are my prefixes, and I authorize my ASM to originate them in, with this MUXLAN in BGP, so nobody else can do that. And everything will be handled by RIPE-NCC. So we will keep your keys, we will manage your key rollovers, we will do all the signing part, all the cryptographic part, and as long as you are a holder of the resources, you will have valid and published certificates. So it's really very easy. But if you want to manage all the RPK infrastructure by yourself, you want to keep your keys, you want to manage all key rollovers, you want to actually create the RPKI ROAS in your own dashboard, then you can go for delegated RPKI, but in this case, you need to run your own certificate authority as the child of RIPE-NCC root CA. Why do you need that? Because they think that you have resources from different service regions, and you don't want to go to the RPKI dashboards of different service regions and create ROAS in their RPKI dashboard, and you can just use unified RPKI dashboard of yours for all the resources from different regions. And in this case, since you are the one running your own CA, you issue ROAS. So you create ROAS on your own dashboard, RPKI dashboard, you sign ROAS, so the signing part, all the cryptographic part, you are responsible for them and you publish them to your repository. There are 2 CA software available. RPKID is a traditional one, let's say, from Dragon Research Labs, and at the end of 2019, MLNet Labs introduced CRIM. Now we have something new. Hosted and delegated. Now we have something in between, which is called as hybrid RPKI or publication as a service. So still, you are actually running your own certificate authority. So you use your own RPKI dashboard to create ROAS, you do the signing part, you manage your keys, key rollovers, but instead of publishing them into your own repository, now you publish them to well-monitored and highly available repository, RPKI repository of RIPE-NCC. That is called as hybrid RPKI or publication in parent, publication as a service, and supported by APNIC, ARIN, and RIPE-NCC. Yeah.
Hi, this is Alexei from Finland. If I've got address space from APNIC that I've signed in my own LIR, can I publish it at RIPE, or do I have to put the published ones into the APNIC version?
So if you have from the other service region, and since you are using delegated RPKI, then I'm not sure actually, but it's up to you, I think, because you decide where to publish it. So you are just actually, it was theoretically possible. For some time, it was possible to publish it with third party. Instead of publishing it into your repository or RIPE-NCC repository hosted case, it's possible actually to publish it to somewhere else. It was possible, but it was not done before this publication as a service or this hybrid RPKI. But now, if you want to publish it to APNIC, you can publish it there, because in your, let's say, certificate authority, in your CA, you are just defining the publication point, right? So it depends on where you want to publish it. So I'm not 100% sure, but it must be possible, because you are just defining where to publish it. If you want to publish it RIPE-NCC, you should do that. If you want to publish it RF, you should do that as well, because it's just publishing with third parties, and now all three actually provides this service. Today we are using RPKI, by the way, to validate the origin of BGP announcements. So which is called as ROV, Route Origin Validation, or RPKI-based route filtering, which is defined in RFC 6811. So what happens? BGP speakers, whenever they receive the BGP announcements, they compare them with the validated ROAs that they downloaded from the validator and make routing decision accordingly. They don't blindly trust this information and put their BGP table anymore. And there are two checks done by the BGP speaker, which is supporting RPKI, which is running RPKI. It will check the origin ASN and MUX length, and both of them must match. If both of them match, then this BGP announcement will be tagged as RPKI valid. If one of them doesn't match, which means it's suspicious information, it will be tagged as invalid BGP announcement. What if my router, my BGP speaker gets an update, but no ROA exists for that prefix? Then it will be tagged as not found, because I cannot say that this is incorrect or untrusted information or it is trusted information. I don't have enough information, so that's why this kind of route without ROAs will be tagged as not found. So after validating, of course, you should do some action, because you are only tagging the route with RPKI status, but it doesn't mean that you are discarding them. Still, you go on accepting them, so after that, after RPKI validation, you should discard them, the invalids. If it is valid, of course, it's trusted information, accept it, and you can put higher, you can set higher local preference for it. If it is invalid, it is suspicious information. Somebody is just pretending to be someone else, so of course, discard it. And if it is not found, ever and never consider dropping prefixes with not found. Why? Because now we have huge number of prefixes announced in BGP, but only for 1/3, maybe a little bit more than we have ROAs for those number of prefixes. But more than half of the prefixes announced in BGP, now we don't have ROAs. So if you actually start dropping not found BGP announcements, which means that you will not be able to see the rest of the internet. That's the reason we should implement RPKI, we should create, we should ROAs, and we should put more and more information in the RPKI system so that we have more data to use, and maybe someday we can discard them, or maybe there will be not found anymore, because once people create more and more ROAs, the number of the not found RPKI BGP announcements actually will decrease as well. And yeah.
Okay, so my name is Jon Schneiders, and I'm participating remotely from.
It's so.
I'm participating remotely from the Netherlands, and I want to add that the best current practice is to not change the local preference or any other BGP path attributes for that matter based on the validation state. So the valid and the not found should both accept prefix and not change anything. Reason being, if ROA is created or removed, or an RTR server crashes, or there's some fuck up somewhere, there won't be any unnecessary routing churn.
Yeah, it's possible. And also the other thing is that I want to mention what was used to do, or what is still being done, most probably there are many networks which are validating their BGP announcements with RPKI, and they tag them as valid, invalid, not found, and they set lower local preference to the invalids, thinking that, okay, now we are doing something good. They are invalids, now we are implementing RPKI, and we set lower local preferred. So, okay, still I accept them, but they are not preferred. It is bad method as well, because if there is no other routing information for that prefix, even if you set lower local preference, which means that it will be best fed and preferred. So that's why if it is invalid, discard it. Do not actually even think about setting lower local preference. And major networks are discarding invalids such as Telia, AT&T, Cloudflare, and many others. And as rightly in CC, we started dropping invalids for AS3333 since April 2021, because we are always promoting and telling people discard RPK invalids, and then we said that, so why aren't we doing that? And we started dropping invalids, and so now only RPKI valid and not found BGP announcements are allowed to access AS3333. So there is again very small demo. I know I'm a little bit over time, but just to show you how it works, it's not something really difficult, so we should do that. Here I have a local cert. Local cert is a test dish. I test RPKI dashboard, by the way. You can use it. It's just local cert RightNet. And whenever you sign in with your LAR account or LEAR account, you will see your announcement and you can create ROAs for them, for your prefixes, before actually creating them in the live platforms. It's just test platforms, so feel free to create ROAs and experience it. I have two ROAs, and you see that one of them authorized AS103 to originate a prefix, which is 193.026.0/24 with the max length /24. And the other one authorized AS102 to originate a prefix, which is 25.0 with the max length /24. And here my validator, I am running two validators, Fort and Routinator, which is downloading all these ROAs from the local cert test RPKI repository, and then it is validating the chain of trust. Now it's ready to push this information to my router with RPKI protocol. And on the other hand, there are some ASs on the internet. For example, AS102 is originating three prefixes. One of them is its own prefix. For another one, as you see, 26.0, it belongs to another AS, AS103. Also, there is a ROA which authorizes only AS103 to originate this prefix. So, which means that definitely AS102 is originating a hijack. And also, AS102 is originating another prefix without any ROA. So two validators are running Fort and Routinator, and this is the configuration I need to do on the router, because when you run the install the validator and run the validator, RPK RTR will come up. So it is ready to send all these validated ROA payloads, VRPs, to my router, but I need to set up my router so that it can have the RTR session and can get this information. Here you see that the configuration is very easy. It may change a little bit from vendor to vendor, but the idea is the same. You need to establish RPK RTR session from your router, between your router and the validator. And now I'm running two validator options on the same server. The IP address you see is the IP address of my server. One of them is running on port 3323, which is the default port for Routinator, and the other one is running on port 323. And then I verify the connection. I should see established state if RPK RTR is enabled. So established. And then I check the RPKI table of my router, which shows that VRPs, validated ROA payloads, or let's say valid ROAs. And as you can notice, here what we see are the VRPs. So the prefix, max length, and origin ASN, which ASN is authorized to originate which prefix, and those are validated, all the key signatures are validated by the validator and sent to my router. And we see actually the same VRP for two times, because one, I'm getting one of them from Fort validator, the other one is from Routinator, so one of the validator fails. It's not a big deal, because still I can get the valid ROA information and make better routing decisions. So let's see what my router will do. My router will start validating the origin of the BGP announcement with RPKI. Now it's getting a BGP update. AS102 is the origin and the prefix is 25.0. So it will compare it with the validated ROA payload that it got downloaded from the validator. And you see that origin ASN and Maxland, both of them are matching, so it will be considered as RPTI valid BGP announcement. For the second example, here you see that AS102 is originating a prefix 26.0, but here actually there is a ROA which authorizes AS103 to originate this. So AS102 is the hijacker. Maybe it's just misorigination, maybe it is attacker, we don't know. And what will happen? My router will actually say that, or will tag this BGP announcement as RPTI invalid. And in this case, my router is getting a BGP update, but for this prefix, it cannot find any ROA. So, which means that I can say RPTI state not found. But always keep in mind that we are not dropping or discarding anything. It is just tagging. We just say that it is trusted information. It is untrusted information. It's suspicious, or I don't have enough information. I don't know. But at the end of the day, we are still accepting that, so that's why we should configure filter to filter out the invalids. So here what it does actually, it accepts the RPTI valid, the filter accepts the RPTI not found. You don't see the invalid RPTI BGP announcements there because there's implicit deny at the end, so they are just filtered out. So to sum up, have proper filters in place. Protect your network. Don't let the others to attack you, and be careful, do not be the cause of the problems. Have proper filters in place, accept customer prefixes from your customers only, not other prefixes, so you can detect the inconsistencies from your peers or from your transit providers when you get the routes. Do not leak them to the other provider or tiers. And for customer prefixes, you can implement IRR-based filters, but always check them before applying. Some manual overrides might be required. Create ROAS, authorized statements in the RPTI system. Protect your prefixes in this way, and also you contribute to global routing security as well. Always keep in mind that if more and more people create ROAS, we have more and more information that we can use to make better routing decisions. And route origin validation, of course, implement route origin validation, validate the origin of the receipt routes when you get them, and it's important to prevent large fraction of hijacks and route leaks. And as you see that deploying RPTI is not that difficult, and it brings big benefits. So go for it if you haven't yet. Thank you very much. I'm just talked a lot, I guess, because of being trained and not talking a lot. Okay. So any questions?
I'm sorry, we're 20 minutes late, so please catch, well, we were 10 minutes late starting, so it's not weird. So big round of applause, please, for Chicken.
I checked actually how Finland is doing. Finland is doing really very great, by the way. So keep up like this, and if you have not actually created ROAS, just do that. But for the time being, for the 70%, that is really very great number. So I congratulate you as well. Thank you.
Okay, thank you again.